So the nice thing of different countries and different people, different languages, is that sometimes your name is unpronounceable for people. So my name has the famous Dutch sound. So Siger, well, that's impossible for most people to pronounce. So in the international British English context, it's more Siger, because only the Arabs can have can pronounce the sound in the back of your throat. So yes, I am a geohydrologist and civil engineer. My bachelor is in civil engineering. So really weird to start talking about forests for a civil engineer, because that's concrete and steel. But my brain is just wired holistically. And I am always looking for the bigger picture. And so in my work, where I started with water, groundwater, then soil, and then I realized, wait, if I can only do this if I also get the natural cycle included. So I got really interested from my work in landscape restoration into the role of nature, and then also realizing, wait, I need to go into agroforestry, because that's the only way how we can make money in a landscape restoration way where you want to use nature. We need to feed the world, but we also need to build nature, and you need to try to combine that. And so this was really how at some point I realized this is like the trinity of the environment. You can only look at water if it's really integrated, if you look at it on an integrated way. If there is water, your vegetation thrives. If there is water, your soil stays moist, and the soil life, all the fungi, the bacteria, everything that is thriving. But it's the other way around as well. If there is soil, then you can have groundwater. If all the soil is eroded, your soil is gone, and you cannot store water in your soil, so you get a flash flood, and after that you have a dry landscape that is just barren and becomes a desert. So you need your soil for having water, but at the same time your soil is where your plants grow, so you need the soil for your plants. And the other thing as well is you need vegetation in order to have new rain. So this is really for me the trinity of ecosystem. Water, soil, and vegetation can only be approached in an integrated way, and if you go for a subset of it, you're gonna derail at some point in your work. At the same time, you need to make a living, so that's the business case in it. If we make the whole world, restore the whole world, and make it one big forest, then we live in cities without food, and so you need to somehow see how to combine it with agroforestry. And trees for me are like amazing things. I am now, my list of things that trees contribute is more than 30, that they contribute to humans, to animals, to insects, to organisms, to fungi, to whatever. They do it under the ground, they do it on the ground, they do it in the air. They prevent erosion, they do nitrogen fixation, they do improved infiltration, mushrooms grow, noise reduction, they function as a windbreak, they even release chemicals that break down methane. So it's like they are the cleaners of this planet. For water, they are really quite amazing as well. A lot of trees can do uptake of water via their leaves, not only via their roots, but they also can take up water via their leaves. They can do redistribution of water via their roots, and they release water into the air via their evaporation, so that they moisten the air. They make that when it rains, the trees make that the impact of the rain is reduced, and at the same time the mulch layer keeps the soil open and prevents evaporation. So they're ecosystem makers. And this combination that they do in the sky of evaporation, of so that there is moisture, evaporation so that there is cooling on the surface, and the seeding of the air with all kind of biological condensation nuclei, the chemicals from the trees, the bacteria and the fungal spores, all those things together, they create an amazing environment for clouds to form. So the tree itself, or the forest itself, because it's in that ecosystem, they add water, they lower the temperature, they add the particles, and poof, then you get your clouds. And this is quite a well-known picture. I think nowadays you have a picture taken somewhere in Australia. On the left, you have your forest, and above the forest, there are your clouds. On the right is your agricultural fields, and there is nothing. So by removing the forests and changing to agricultural fields, your cloud formation stops. And then well, that's what we saw in Europe this summer, really dry and really hot, and lots of places I'm from Europe, so I see the news, but lots of other places are facing similar issues. But we make it even more stupid. We start removing forests for solar panels. And there's enough wasteland where you could plant solar panels, but let's remove the forest, burn it so that it can be used for biofuels. And then you see here on the picture, it had rained and the forest is making new clouds. And the solar panels are just heating up the soil, and nothing ecologically for water recycling happens there. And it's fascinating, this kind of stuff, where a road can be a place that is so hot in the day that it cannot rain. So there is that interaction as well. The road, the tarmac, the black tarmac absorbs all the heat, and you get a very hot column of air, and it can't rain there. So the forest next to the road has rain, and the road itself stays dry. I mean, of course, you need certain circumstances for it to happen, but this shows again what the impact is of removing the forest and changing the landscape. But also another thing is what happens if trees are removed. These are pictures, one study, the left one is in France, the right one is in Spain. And the left one, that was a 10-year research project where they really researched everything, and you see it here nicely depicted. You have your trees, they moisten, you get this thermal convection, they have the the aerosols, and you get your cloud formation above the tree. Halfway the study, there was a tornado and half of the forest was removed. And what happened? The forest only where the forest still was, that's where the cloud formation happened. And where the cloud was removed, cloud formation was strongly reduced. So the forests, they make their clouds. The picture on the right is from Spain. And what you see is the Mediterranean Sea is bringing in a certain amount of water. And in the original situation on the top picture, the wind was blowing over the forest, and the forest and the swamp was adding water so that it reached the critical mass, the critical amount of water, resulting in cloud formation, resulting in rainfall. And that water, this is in the summer period. In the paper of Milan, he is saying this water probably circulated 7 times. Rainfall going to the clouds add their 1/3 of the extra water moisture that's needed, and you get cloud formation again, and you go around and around and around. So your water is just continuously, really quickly recycled every 10 days, somehow. Due to tourism and all kind of developments, a lot of the forest was removed, the swamps were drained, and the rain is gone. There is no more water added to the atmosphere, and it doesn't reach the critical level anymore, and your rain stops. That's what the whole biotic pump papers also show. These are a few cross sections. What you see is you have the cross sections in the left. You see the blue are the forests that bring water, and the red one are grasslands and worse. And what you see is where there are forests, you have an increase of rainfall the further you are away from the coast. So if you have, for example, 1,000 millimeters on the coast, the further inland it increases. And that's fascinating. So that's the whole biotic pump discussion that happened there, that concept that apparently there's more moisture must come from the sea, because otherwise you can't have an increase of rainfall. The other way around is when there's no forests, you have rainfall and it just disappears, and after a while it's totally dry, so you end up with a desert. On the right, there are the green on the top, there are forests, and the red, pink, and the red and the purple ones and the blue one, they are more the deserts. The most interesting one is the number 4 and 5. That shows that are two transects that start with a forest, and then after that the forest is gone. And what you see is when you have a forest, the rainfall stays the same or slightly increases, and when the forest is gone and you go to a different land use, the rainfall decreases. So you need to have these forests in whatever direction you are on the world. That was my first thought, like, wait, which directions are they going? But it seems to happen everywhere. It doesn't matter if you're in Siberia or in Congo or in Alaska or in the middle of the US, transect number 4, or in the Amazon. Everywhere it happens. Forests keep the rain, increase the rain, and no forests seem to make it drier. But interestingly enough, I discovered as well recently that to me, it's like they even reduce hurricanes. This is the picture of all the hurricanes happened since 1840. And between 1840 and 1940, the data is relatively unreliable because it happened based on ships who were logging their hurricanes. But from 1940, especially 1960 and on, the data is pretty reliable. These are all the hurricanes, tropical storms, extreme weather events that have been observed. Along the equator, there's nothing. That's due to the turning of the Earth. But interestingly enough, why is there nothing happening around Southern America and the west coast of Africa? What's happening there? I think that's because of the forests that are there. And what's happening now, if you look on this picture, you see that the Sahel and tropical Africa, that's forests, and you have the Amazon and the Atlantic forest in Brazil and Argentina. That's all forests. So there is apparently they do something that makes that no hurricanes happening. But we now have removed already in the last 10,000 years a third of our forests, and half of that removal occurred in the last century. And if we continue in the rate we're removing the forest, we will have no forests left in 400 years. I mean, I will not live that long, but still, that's not nice future to predict. But we have also to realize if we plant trees, you have trees, trees, and trees. I mean, I once found these pictures. It's like, what? This is like a tree. I've never seen, you in the US have a few of these trees left, but this apparently occurred in more places. They're all gone. And so these trees that are ancient, old, that are 1,000 years more, they have their ecosystem below the ground. They have their mycorrhizal fungi network. They have all these chemicals that they release, and they are much more ecosystem makers than just the new planted tree that we do ourselves. And it takes, if you look at the life and syntropy from Ernst Gotch, it took him 40 years, and now he sees the ecosystem is changing. So yes, we can make our ecosystems, but it takes some time. And yeah, the bigger the tree, the better their geoengineering, so to say. But a lot of the Amazon and the Atlantic forest in the south of Brazil is largely gone, and a lot of the Amazon is going. And so since 2000, these 3 hurricanes have occurred in the south of Brazil, 2004 and 2 in 2010. And so for me, that shows what trees do: moisten, cool, and put all the condensation and nuclei in the air. That is changing, which means that the weather is changing, and that then Brazil will face more hurricanes. So for me, it's really like these forests, they are just amazing, and they can be an amazing power to help us mitigate climate change and reduce it. But at the same time, our challenges, our environmental challenges are huge. We need to feed more people because the population of this planet is still growing. We want to move away from oil-based, fertilizer-based farming to become more carbon neutral. We need to stock more carbon in the soil. We need to save our biodiversity. We need to cool and rehydrate our lands, especially the lands away from the oceans where the forest brought the rain. And so for me, this is really, we can only do that with trees, but we need to integrate it all together. In the Netherlands, there is the food forest pioneer. He has his forest. He did a very interesting research on his plot: biodiversity on his land versus biodiversity in a nature reserve 10 kilometers away. And on his food forest, he had a bigger biodiversity than on the nature reserve 10 kilometers away. So if you really design it well and make it true polyculture, you can do a lot of these things that our challenges are for the future in agriculture. And so that is where my passion for agriculture comes in. So agroforestry, this is, I find this a nice triangle to show what agroforestry is trying to do. In agriculture, in a farm, in livestock and in trees, we all went to the most efficient system. So 100% trees and nothing else. 100% livestock and nothing else. 100% crops and nothing else. And then you go into these monocultures that just will be invaded by pests, will be invaded by, or are too hot, or are whatever, depending on external inputs. And so we need to somehow seem to integrate it. And some solutions, silver pasture, that is bringing trees into your livestock systems, alley cropping, where you put your trees in a row, the food forest or the forest gardens, or the windbreaks. And for me, the windbreaks is really the biggest no-brainer that everyone should just do. So I will show you a few things about it, because in the end, that's all about design. As everything is about design, bringing the right things together. But for me, the 4 crucial things is: you need to know where the wind comes from. You need to know how dense you want to make your windbreak. Where do you place your opening? Because the wrong opening can make things worse. And what's the distance between the rows if you make multiple windbreaks? But these are 2 pictures that are really interestingly showing the impact of a tree on the landscape. I mean, even three individual trees seem to have an impact on the crops that are growing there. I don't know if it's positive or negative. They stay green, but maybe that's too late in the season. I don't know. I can't say that based on, I don't know when in the season these pictures are taken, but it's interesting to see how much impact those trees have on the landscape. So where the wind comes from, windbreaks you can use for multiple things. It's noise, it's wildlife, it's summer winds, winter winds, the good winds, the bad winds, the shade, fire. So this is a nice, you need to determine that for your whole place to know which wind do I need to block and which wind do I maybe need to have. But you need to also know if you have a bad wind, what is the strength of your wind. And the Griggs-Putnam index is a good one to use nature for that as well. If you have no wind data, to just determine how much the more the tree or the shrub or the plant that's growing is deformed, the stronger. Then you can, with the Griggs-Putnam index, you can determine have an indication for your wind speed. So people have already done that. And then you need to realize your windbreak. If you make it totally closed, you just create a vacuum. If it's just a blockage, you create a vacuum and you get your turbulence behind it. So you need to make it somehow open a bit porous, so that the wind can go through, but it's still strongly reduced. And that's crucial for your windbreak design, to make it not 100% closed. Second thing is, where do you make your opening? If the blue lines is your main wind, and you think, well, the red is my house, and I don't need to continue the windbreak close to my house. Well, you could make a wind tunnel that makes that it goes through there and then around your house, so that it's worse. So maybe you should just close it. But it's just thinking that kind of things, like how where do you make your openings to go through to enter your house, because you might want to enter your house at some point. That's why it's your house. And then, of course, if you make multiple windbreaks on your land, you need to know where to make them. I mean, there's lots of interesting studies done in it with the porosity, but more or less they say around 10 times the height of your windbreak is where it's effective, and there you should build the next windbreak. Otherwise, the wind picks up velocity at the surface again. And the results are quite impressive if you look at all the data that's there. You get better microclimate. You can get earlier germination for your seeds, improved plant development, earlier harvest, improved harvest even up to 40% with really different crops. They have studied it. Potatoes, maize, apples, strawberries, lettuce. It seems like everything seems to be investigated. At the same time, you have to realize that with windbreaks, next year windbreak, you probably have, due to root competition, you might have less harvest, but that's why also you shouldn't make it too close. So for me, to conclude, I mean, trees are just amazing creatures, and in a forest, in an ecosystem, they really create the environment. They create below the ground, on the ground, and in the air. They create their environment. They stabilize the climate, they cool the air, they make it moist, they make it rain. Everything that we as human beings need, the trees can do for us. So removal of our forests, it destabilizes our climate, and we have to bring it back. And with the other challenges we face, for me, it is the only way how we can do it by including it all together in a very good, well-designed, using your human brain, agroforestry type of system.